For centuries, people have asked, why can a salamander regrow a limb but I can't? Salamander regrowing a limb. Me, looking at my hand, wondering. Turns out the answer might not be the genes we have, but the air we breathe. A new science paper from April 2026 just dropped. Plot twist: mammals might still have the instruction manual for regeneration. Our cells just slam the brakes when they sense too much oxygen. Researchers compared regenerating amphibian limbs with embryonic mouse limbs. Early on, mouse tissue looked surprisingly similar to a frog that's about to regrow. But under normal oxygen, the mouse wounds stayed open. They laid down extra cartilage and didn't kick off regeneration. Then they dialed the oxygen down to about 12–16%. Boom. Wound closed fast, made less junk cartilage, activated stem-like epithelial cells, and turned on regeneration genes, basically looking like the early stages of a salamander comeback. The key player is a protein called HIF1A. Think of it as the low oxygen switch. In normal oxygen, cells shred HIF1A. In low oxygen, HIF1A stabilizes and flips on a whole network for repair and regrowth. Keep HIF1A active, and mouse cells start acting. Salamander-ish. Skin cells migrate. Scar-prone behavior drops. Developmental genes wake up. Even cooler, they mimicked low oxygen with a drug that stabilizes HIF1A. No special chamber needed. That hints at future treatments that work locally, temporarily, and precisely. Now, closing the wound isn't regeneration. True regrowth needs a blastema, a flexible pool of cells that can rebuild complex structures. Low oxygen alone didn't get all the way there, so the team added a cocktail of growth signals: BMP4, FGF10, EGF, CHIR99021. With that combo plus low oxygen, the tissue flipped on classic regeneration genes like FGF8, SP8, DLX5, WNT5A, and shifted away from cartilage toward a blastema-like state. So why can salamanders do this naturally? Their cells are way less sensitive to oxygen. The genes that shut down HIF1A are dialed way down. Mammals, including us, evolved a super responsive oxygen sensing system, high metabolism, warm bodies, big brains, and guarding against runaway growth. But that same system may slam the door on limb regrowth. What does this mean for medicine? We might not need to rewrite our genome. We might just need to carefully control oxygen sensing and the right growth cues at the wound site. Imagine localized, low-oxygen microenvironments. HIF1A stabilizing compounds. Smart biomaterials that deliver growth factors, helping severe wounds, bones, nerves, even post-surgery healing. But, huge caution flag. The same pathways that help regeneration can also help cancer. Any future therapy has to be localized, temporary, and tightly controlled. Big picture, maybe humans didn't lose regeneration. We locked it behind an oxygen-sensitive switch. And now, we're learning how to turn the key.